Good morning, everyone. I'm Indu S from Department of MCA. Today, I'm going to present my machine learning unit one assignment for on the topic supervised learning versus unsupervised learning. For this presentation, I have created my own sample scenario based on student performance and study habits. um, I will explain how the same sample data can be used for both supervised and unsupervised learning. So let's begin. The real scenario. First, let me explain the scenario that I have selected for this presentation. Imagine that an MCA class wants to understand the study pattern and academic performance for its students. We have some basic information about students such as their study hours, attendance percentage, previous examination score, and their result. Using this information, we can ask two different questions. First, can machine learning predict whether a new student is likely to pass or fail? This can be solved using supervised learning. Second, and machine learning discover groups of students who have similar study habits. This can be solved using unsupervised learning. So I'm going to use the same sample scenario to demonstrate both approaches. What is machine learning? Before going into supervised and unsupervised learning, let's understand what a machine learning means. Machine learning is a branch of artificial intelligence that enables computers to learn patterns from data. In traditional programming, we provide rules and data, and the computer provides an output. But in machine learning, we provide data and examples of output. The system learns a model or pattern from them. After learning, the model can be used to make prediction and decision for new data. For example, instead of manually writing thousands of rules to identify spam mails, we can provide example for spam and non-spam email, and the machine can learn the pattern. A sample data set. Now I could like to introduce the sample dataset that I have created for this seminar. This dataset contain 8 sample students. First column represent the student name. Second column represent study hours per day. Third column represent attendance percentage. The fourth column represent the previous examination score, and the final column represent the result, either pass or fail. For example, Aisha studies for 2 hours, has 65% attendance, and has a previous score of 55, with the sample result marked as fail. So similarly, Gokul studies for 7 hours, and he has 92% attendance and has a previous score of 88, with the sample result marked as pass. These two are these are our sample data sets, which we are going to use for supervised and unsupervised learning. Supervised learning. Now let's apply supervised learning to our dataset. Here the important point is that we already know the result of the students in our training data. The result is either pass or fail. Therefore, result become our target or output, while student has attendance percentage and previous score are the input features. The machine learning model learns the relationship between these input features and known result. After training, we can provide information about a new student and ask the model to predict whether the student belongs to the pass or fail category. Because The output is a category. This is the classification problem. This is called a supervised learning because the training data contain the correct answer or label. Now let's consider a new student. Suppose the student studies for 5 hours per day and has 86% attendance and has a previous score of 76. We provide these features to our trained model. The model compares this new student information with the pattern that it learned from the previous sample data. Based on those learned pattern, the model can predict a class such as pass or fail. In our demonstration, the predicted result is pass. Unsupervised learning. Now let's look at the same scenario from a different perspective. For unsupervised learning, we remove the result column. Why do we remove it? Because unsupervised learning works with unlabeled data, while supervised is work with labeled data. Now the machine only receives information such as study hours, attendance, and previous scores. We don't tell the machine which student belongs to each group. Instead, the algorithm analyzes similarities between the student and discover groups by itself. For example, it may discover a group of students with high study hours and high attendance, another group with moderate study patterns, and another group with low study hours and attendance. This process is called clustering. Clustering our data set. Here we can see a sample of how our student could be grouped based on similarities. The first group represent student with high study and high attendance. The second group represent students with a moderate study pattern, and the third pattern represent student with relatively low study hours and or attendance. The important thing to understand is that these groups are not given to the machine beforehand. The machine discovers the group based on similarities in the data. Therefore, clustering is an example of unsupervised learning. The main idea is similar data points are grouped together. Comparison. Now let's compare supervised and unsupervised learning using our own scenario. Supervised learning uses labeled data, while unsupervised learning uses unlabeled data. In supervised learning, our goal is to predict the result. For example, such as pass or fail. In unsupervised learning, our goal is to discover groups of students with similar student patterns. In our example, classification is used for predicting pass or fail, while clustering is used for discovering student groups. So, the simplest way to remember the difference is supervised learning means learning with known answers, unsupervised learning means discovering pattern without known answers. Classification and regression. Classification. Classification is used when the output is a category. In our scenario, pass or fail is a category, so it is a classification problem. Regression is used when the output is a numerical value. For example, instead of predicting pass or fail, if we wanted to predict a student's final percentage, that could be a regression problem. Therefore, classification predicts categories while regression predicts numerical values. Benefits, limits, and responsible use. Machine learning has several benefits. It can help us identify patterns in large amounts of data and support data driven decisions. Supervised learning can make predictions when good labeled data is available. Unsupervised learning can help us discover hidden patterns without requiring labeled data. However, machine learning also has limitations. Supervised learning requires labeled data, which can take a time and effort. Poor data or biased data can also produce poor results. Therefore, machine learning predictions should be used carefully, especially when making important decisions about. Human judgment is still important. Human judgment is still important because sometimes mission predictions may be gone wrong. Conclusion. To conclude, a machine learning allows computers to learn useful patterns from data. Supervised learning uses unlabeled data to make predictions. In our scenario, we used supervised learning to explain how a model could predict a student's pass or fail category. Unsupervised learning works with unlabeled data and discovers hidden patterns or groups. We used clustering to demonstrate how students could be grouped according to similarities in their study habits. So, the key idea is labeled data leads to prediction, while unlabeled data helps us discover pattern. Mm, Thank you for listening to my presentation.